I space it out so easily. It's like I try to be so in the moment and then it's like, oh no. Okay, number one, you do have class on Friday. Okay, one of my FM instructors, Scott, is coming to teach it. Scott is totally awesome and cool. Like when I started my position here, my hands picked him. I was like, please come and work with me. So you guys will really like him. And he teaches Math 115 all the time, and he's just going to do it totally my style. I have to do this retreat with the president of the blah 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 in the morning. So I'd rather be doing that very quickly now. Excuse me?
Doesn't sound like much of a retreat.
I know, it's really funny what they call retreats. So I had a retreat the Monday before the semester started. It was a day-long retreat. Because I'm like head of faculty governance here. And it was literally, I was in a room from 8:30 to 3 in the afternoon, listening to people talking. I'm like, is this really a retreat? So my version of a retreat is, since I run the math discipline over here, I guess I'm in charge of all of the people who teach math here. I don't like to think of myself as in charge because we're all friends. But so my retreat that I have with them this summer is we wanted to like revamp various curriculum and courses and talk about like things we want to do moving forward. And that was when the no final exam in Math 115 was decided. So that retreat was very beneficial for all of you. But I live 40 miles south of town. I live in a log home. I don't have a lot of land, but I've got 7 acres, and I like to grow my own food, and it's just a sweet place. So I had them all down, and they all spent the night, and we ate, and we hung out, and we did fun things, and then we talked about the next day. So that's a retreat, right? Food. Anyway. Free food's a good thing, though, and I will get that right. So, in terms of class, yesterday we got to start the math, which is really exciting. If anyone missed it, sorry, don't worry about it. After class, I always post the recording and the class notes to the box folder. The link to the box folder is on our Moodle page. So, again, if you missed something or you just want to re-listen because you just couldn't get enough math the first time around, I'm kidding, then you can access it there. Yeah.
Do you have any copies of the syllabus?
I can make some hard copies of the syllabus if you would like me to. How many people would like a hard copy of the syllabus? Okay, I will make them, and I'll either bring them Monday or have Scott bring them on Friday. So I won't see you all till next Tuesday after today because we don't have class on Monday. You're welcome to come here. I'm not going to, but at least I hope not. But anyway, yeah, I will definitely bring hard copies. I used to make copies for everybody, but then most people didn't use them, and then you can get them on various sites. So I just kind of like, I don't want to wait for 5 but yeah, I'm happy to make copies. Totally. Thank you for asking. So my hope is that class went okay yesterday. The math that we started talking about. Does anyone have any questions on anything before I pick up where we left off? No, there is class Friday, Danger. That's called wishful thinking. My friend Scott is going to be teaching class on Friday. Yeah, I have to be somewhere. So yeah, So don't miss class. I mean, I'm giving Scott all my notes that I want him to talk about, so I'll just pick up next Tuesday where he left off. But we don't have class tomorrow. Remember, we only have class 4 days a week, so Thursdays you kind of get a little break from the math, for better or worse. Y'all okay? Yeah,
Where should we be checking for the assignments? That in the my book.
okay, that's a great question. When we are ready to start working on a homework assignment, I will literally bring you there in front of you, show you exactly how to access it, set the due date right in front of your face. Okay, so at this point, so please know that nothing is ever left to the imagination. When you have an assignment, I'm going to tell you, and it'll like literally be in your face here. Okay, I'll show you exactly how to access it. Again, what you need to do right now is to keep up with the class notes, review them so that, you know, especially between Friday and Tuesday, because something tells me you're probably going to think about a lot of things non-math related between them. So, you know, reviewing your class notes before class, just so that you have that continuity, is really important right now, and making sure that you're registered on the MyOpen Math site. 13 people so far in this class still need to register on the MyOpen Math site. It's not like it's too late by any stretch, but please make sure you do that, because then you're able to jump in right away. Okay, and I got an email question from someone in the class yesterday evening asking about how to get in and access it, the enrollment, the course code and the enrollment key. That's in your syllabus, and your syllabus is connected to the Moodle page. So that in your syllabus, there are literally step-by-step instructions on how to access the MyOpen Math. Any other questions? All right. You ready to do math? Sure. Okay. Yeah. It's exciting. And I promise you, you know, things will pick up, not in a bad way or a stressful way, but, you know, right now there's a break where you don't have homework. What I'll say to you all is savor the moment. Okay, you know, as I told you before, I'm very conscientious about the fact that you have other classes and you have lives outside of school. So I never ever overwhelm you, because that's just going to make you mad and turn you off of the class. But once we start moving and developing the material, you'll at least have steady work, but never overwhelm. Okay. And once we get through these Venn diagrams, I will also have a worksheet for you as well. But we'll do that next week. Cool. All right. So let me pin my screen. Cool. And those of you who are zooming in, if you have questions, please put them in the chat box. We have people here who are very hopefully alerting me to it. All right. And for those of you who might be interested, there's an open house here for students. Free food from 4 to 6 today. I believe downstairs in the Blackfoot Cafe. If you have nothing else to do from 4 to 6 and you want some free food, right? Free food's a beautiful thing. And I'll be down there and you can shoot the breeze, and just thought I'd mention it. You are welcome. All right. You ready? So yesterday I drew, I do know how to speak. I drew a 2-circle Venn diagram, and what we did is we talked about like what the various regions mean. And I know that it seems like I'm being really uptight about how we identify each region and the words. But trust me, I'm planting these seeds now and I'm really emphasizing them because I promise you I'll help you moving forward. Okay, so what I want to do is now show you a 3-circle Venn diagram. We're not going to get any bigger than 3-circle Venn diagrams. And honestly, on exams, you're just going to have a 2-circle Venn diagram, but online homework, you'll have some 3-circle Venn diagrams. But I think it's important just to be able to start identifying those regions as well. Cool. So an artist, I am not. But this whole thing, there was a question after class, that whole box is our universe. Remember, the universe is relative to whatever it is that we're talking about. But that entire box is my universe. Someone asked me, why did you put the U in here? You can put, remember this is the symbol for universe. You can put it outside here. It just means everything in here is part of our universe. Cool? Okay, so we can have 3-circle Venn diagram. Things get interesting very quickly. Okay, now this is just one example of what a 3-circle Venn diagram could look like. And I'm just trying to talk you through what the various regions represent. Okay, everything in here is in my universe. Let me stand up on here. Okay, now I can see you all. Everything in here is in my universe. Notice my circle A right here actually contains 4 separate regions, doesn't it? Okay. And I'm just going to talk you through this. So if I wanted to identify what's in my circle A, that's this, and this. Okay. So what do these various 4 regions mean? Well, this is only in A, right? Okay, if I want to talk about what's in A and B, that's where A and B overlap. But notice A and B even consists of 2 regions, right? Like this part I could say is only in A and B, whereas this part is in A and B and C. You see the difference between those 2? I mean, we're being very literal. The overlap is where that happens. So also then, like this region right here, this slice, this is in A and C. This is only in A and C, right? Notice it doesn't intersect my B circle. And what would I call this region here? Only what? Only B and C. What would I call this region just right here? Only C. Okay, we're being very literal here. So this is A and B and C. This is where all 3 things overlap. And one of the things that you're going to learn as we proceed through this stuff is that when we fill in Venn diagrams, we always start with the innermost region first, like the most overlap. We always work inside out, kind of like PEMDAS when you did the order of operations, right? You always work inside out when there's a whole lot of parentheses. Same thing translates over here. All right. So these things get complicated very quickly, but again, we're not going to get too deep into these 3-circle Venn diagrams, and we will be doing word problems. And if you're wondering what sort of applicability there is, take a deep breath. We will get there.
Okay, we first need to learn how to do set operations, and then we're gonna jump into word problems, because really what happens in life, I mean, you're not taking this math class because you're math majors, you're taking this math class because there's hopes that it's applicable to whatever it is you're majoring in. And so, you know, I really try to make this a very relevant and applications-based class. Okay, so be patient with me. You will get word problems. And also be patient with yourself with word problems. It is my job to walk you through them and help you learn how to translate them, because I know that that translation is probably one of the hardest things for people. All right, so we talk about sets, and that's just fine and dandy, but just like when we talk about numbers, we like to do various operations on our numbers. We like to do various set operations. Now, there's 3 set operations that we're going to be talking about. And what I want to say to you is I'm going to show you each of them individually. Sorry, I've say a frog in my throat. Anyway, I'll show you each of the 3 of them individually, and then we're going to start putting them together. Other thing that I want to say, don't expect that you are just going to memorize it. Okay, have these things in front of you. Memorization is not a part of this class. So as you're practicing and getting yourself used to these set operations, you know, please have that in front of you to refer to. You'll get the hang of it just through practice, but give yourself the time and space for that practice. Okay, so our very first set operation is called the complement. Okay, now when I talk about various set operations, I'm going to give you keywords. Again, these are keywords because they're going to help you not get lost in the translation part. Not is my keyword for that. Okay, so when we talk about the complement of a set, what I'm going to tell you is it's everything in the universe that is not in that set. So for example, and I'll draw a picture because pictures are worth everything in mathematics. If I'm talking about my set A, and I want to talk about the complement of it, there's actually 4 different ways that you can show the complement of A. Okay, and I just want you to be alert to them because you're going to see them different ones in your homework. Don't get caught up in the notation. But when I'm talking about, for example, the complement of A, I can write that as A with kind of an apostrophe. Another way to write that is A kind of raised to the power of C, if you will, but that says A complement. Another way you might see it is an A with a bar on the top, or you could have this little tilde A. This is probably the rarest one, but the point being that any one of these says that you're looking at the complement of A. So you might be like, oh, right, what does it look like? Yeah.
Why is there so many different ways to say
I can't answer that question.
that? Which one would you like us to use?
I would like you to use whatever you feel like using, and honestly, it's not going to be very often that I'm going to ask you to find the complement of a set, but you know, these 3 come up pretty frequently. Yeah, if there's more than one way to write it, I'm not particular. Okay, but just know that that's what any one of those symbols means. I mean, this one kind of irritates me. If one can express irritation about such things, because in mathematics, when you have this mark right here, that's kind of a derivative if you're doing calculus, and so, you know.
I was wondering where I've seen that before. I'm like,
Yeah, it looks like A prime. So what does the complement of A look like? Well, I think a picture is worth everything here. So I'm going to draw a couple alternative universes. Okay, here's one universe, here's another universe. Here's my set A. And over here, I'm actually going to draw a couple sets, A and B. So if I want to shade where A complement is, remember, by definition, everything in the universe that's not in A. So what you would do is you would cover up A and shade everything else. Out here is A complement. You dig? Now, when you have another set involved, like if I want to talk about what is A complement in this second one, notice there's another set B here. We don't care about B. B is totally irrelevant here. If I want to shade the complement of A, I cover up A and it's literally everything else. So do you see how the word not relates to this? Sweet. Are you thrilled? Awesome. All right. This one, when you talk about the complement of a set, you need to know what your universe is in order to talk about the complement. And I'll show you this with examples of sets and everything. Right now, I'm just defining it. What?
So is the middle section shaded between A and B?
No, because that's in A. It's everything except A, and that's a beautiful question. You're awesome. All right, our next set operation, and don't worry, we're going to be going through a ton of examples before I set you loose doing them on your own. Okay. The next set operation we're going to talk about is the intersection of two sets. So if I want to talk about the intersection, this only has one notation, friend. Okay, it's A that is intersect B for horseshoe. Now, to me, the key words for intersection, and again, this is very important moving forward. It's and, or you could use the word both. Essentially, it is what is in A and B at the same time. In other words, where they overlap. So I'm going to draw a couple alternative universes here again. And in this universe, this is where A and B live. And in this universe, this is where A and B live. So if I want to shade the intersection, it's literally what's in A and in B at the same time. It's where they overlap. Okay. Notice this stuff is not in the intersection because it's only in A. You with me here? Okay. How about over in this other universe here? There is no intersection. Okay. So what we would say here is we would say A intersect B equals the empty set. They have nothing in common. When two sets have nothing in common, we have a name for them. Anyone's ever disjointed their shoulder or something like that? It's what I always think of. It's called disjoint sets. Is that a term you need to memorize? No, but it's a term you're going to see, and I want you to understand it. It means they have nothing in common. Y'all with me this far? Okay. All right, our third set operation is the union. And the way that you write the union is it's essentially like a cup or a union B. And when we talk about this, we're asking what is in A or in B or both. Okay, so the key word here is or. But in this version of or, you have to allow that they can be in both. One can get very particular. We're not going there. There's the inclusive or versus the exclusive or. So I don't really go out to eat very much because I feel like I can cook better and I like knowing what's in my food. You know, when you go to these restaurants, when you order some entree and then they ask if you like soup or salad, they don't mean that you can get both, right? They mean one or the other. I mean, my answer is always, yeah, right? But, they're not allowing for both in there. That's called the exclusive or we use the inclusive. Okay. Don't sweat that stuff, but it's things I need to point out. So if I'm going to draw a couple universes here, if here's A and here is B, I claim that my union, well, is this stuff in my union right here? Is that in A or in B or in both? Heck yeah, it's in A. How about this stuff? Yep, it's in both. How about this stuff? Yep, it's in B. How about this stuff? No, it's in neither one of them. What if I have A here and B here? When I'm shading the union in that Venn diagram, is there anything that I shade? Yeah. I shade my A and I shade my B. There just doesn't happen to be a both. So when you're talking about the union of two sets, you could care less what they have in common. You just put them together. Okay? You don't double list whatever they have in common, but literally it's just putting them together. You with me this far? Okay, so biggest difference between the words and or. It's kind of a thick example, but still like. Let's pretend that I'm alive and I am whole. Okay, in other words, I have not been dismembered. Okay. So, can I be right now in Montana and in New Mexico at the same time? No, there's no way I can be in both places at the same time. Again, I'm not dismembered. Okay. Would it be correct for me to say that I'm in Montana or in New Mexico right now? Yes, because I'm in Montana. So as long as I satisfy one of them, I'm cool. Okay. Notice I didn't say Montana and Idaho or any other bordering state because I could straddle it. Okay. So, and an or, it might seem kind of silly, right? There's just a difference of one letter, but it makes a very big difference when you're talking about two sets with the intersection or with the union. So the moral of the story right now is when we're talking about the complement, it's not A. That's what I want you to learn. And you'll notice I'm stressing this and I'm not stressing this, you know, to be a pain. I'm stressing it because it is stuff that I want you to take with you. When we talk about the intersection, our words are both, or we can use the word and. And when we talk about the union, our magic word is or. We're only going to be adding one more magic word this semester, and that's it. We'll get there. So what I want to do right now is practice putting these together, okay? Now, the first thing that I'm going to do is I'm going to have a shade Venn diagrams, putting these things together. But then what I'm going to do is I'm going to show you examples of that, where we actually list the elements, and then we're going to play that way as well. Sound good? And then you will have the opportunity to play with some verbal descriptions too. So what if I want us, and honestly, a test question for me is not shading a Venn diagram, okay? What we're doing right now is we're kind of doing the building blocks because I need to get you to a certain level of understanding and familiarity so we can start moving forward, okay? What if I want you to shade A complement intersect B? Well, first off, whenever you're doing these sorts of exercises, do it in steps, especially when you have three circle Venn diagrams. I mean, like, don't try to do it all at once. Okay. Number one, it's important to show every step on a test because you get partial credit, right? I always ask you if we show all work for full credit because you can make a mistake along the way. If you make a mistake along the way, I want to be able to track your mistake and find out what happened. So don't ever expect yourself to be able to look at a Venn diagram and just shade it immediately. Okay. Now we're going to be bringing in parentheses, and that whole thing with the order of operations that you once knew and maybe still know, right? PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. It kind of sort of still holds here. You can think of this as an exponent. In other words, what we're going to do here, I'm going to do this in 2 steps. In purple, I'm going to shade A complement, okay? Do you agree A complement is everything in the universe except an A? Okay, well, first I should label so we know where A is. Okay, so instead of shading, because it can get messy, I'm just going to put little X's in where I'm talking about. So do you agree A complement is here and here? Any questions? Okay. Now I'm going to indicate where my region B is. Do you agree B is this entire circle here? So it's this region and this region. Notice all I've done thus far is identify where each of those sets exist. Now I'm going to do my application. I'm going to do the intersection. In other words, I want to know what's in A complement and in B at the same time. In other words, where do I have a purple X and a black X? Just here, correct? This part isn't in the intersection because it's not part of anything. This part's not in the intersection because that's only in B. This part's not in the intersection because it's only in A complement. So my answer is right here. Does that make sense? Cool. Now, to contrast the intersection versus the union, now what I want us to do is shade what is A complement union B. I think the unions are not as exciting. They are less work. Can I explain why it's not shaded on the outside? Absolutely. Thank you for asking that, Riley. This is not shaded on the outside because I'm interested in where I have an X for a complement, in other words, a purple X, and an X for B, a black X. Remember, the intersection has to satisfy both, and this only has one X in there. It only satisfies one. This is the only place where I've shown both. Does that make sense? Cool, thank you. Thank you for asking. You're super cool. Now, notice it's the same two sets. So I've already identified up here what is A complement and what is B. What do I do with the union? Well, remember that's or. It needs to be one or the other or both. So let's figure out where we're going to shade. Okay, given this is A complement, given this is B, am I going to shade right here? Is it in one or the other? Yeah. Am I going to shade right here? Yup. Am I going to shade out here? Yup. Am I going to shade in here? No. So when you're doing the union, literally all you need to do is shade one, shade the other, and walk away. The intersection is what they have in common. The union, you don't need to have commonality. So my cynical side is like, you know, they talk about marriage and union, right? You're putting two families together. They probably don't have a heck of a lot in common. So, anyway. My cynical side. All right. Now, is this okay so far? What if I want us to shade? I'm gonna do two more today. Sound like a plan? Okay. What if I want us to shade A complement intersect B complement? Again, the first thing that I would do is identify each of these regions individually. Okay. So A complement, tell me, how do I identify that on my Venn diagram? Not in A, so cover up A, it's everything else. Questions this far? All right, let's do B complement. How do I do B complement? Everything that's not in B, so I literally cover up B, and isn't it this region and this region? Hey, if I was doing the union, I would walk away and be like, yo, it's wherever there's an X, I'm done. Okay. But I'm doing the intersection. In other words, I want to know where I put each color X.
It's just the outside, it's just the.
It's just, well, the whole thing is the universe, but yes, absolutely. So your answer here, since we're doing the intersection, is just out here. All right, one more. What if I want us to shade A intersect B complement? Hooray, we have parentheses. It means we have some more work to do. Okay, so how do you deal with parentheses? This is where your order of operations come in, right? You always do what's in parentheses first. Okay, so where would I start here?
Start with that one.
Okay, what I would do is I would work inside out. In other words, where is A intersect B? Tell me where to shade. Good, I shade my overlap. This right here is A intersect B. I want you all to know that.
Then it's like outside of everything, and it's like, nothing that's upset.
Okay, so now everyone cool with step one? Cool. So we know the set now that we're wanting to take the complement of. In other words, my answer is everything in the universe that's not in where I shaded. So it's this region, and all of this mess out here. Because I'm taking the compliment. You make great facial expressions. Seriously, I saw it when you got it and I love that. I love that. Are there questions this far? Now, we're gonna actually get into like real sex. You're gonna be doing that on Friday. But this is a good breaking point, so enjoy getting out of class a little early. I won't see you till Monday, or Tuesday, but Scott will be here on Friday, so please come, it's class for real. I hope you all have a beautiful weekend and then you feel okay in the class so far.
So if that's opposite, you should have just the building. So it's union. A union.
Oh, if-
complement.
Okay, so let me,
Uh,